Now for the Chapter 15 slides on world climates. Early climate classification. An early attempt at climate classification by the Greeks divided each hemisphere into 3 zones: torrid, temperate, and frigid. There's a picture here of the Earth divided into 3 sections. So the middle of the Earth, between the Tropic of Cancer and the Tropic of Capricorn, is the torrid zone. So that includes the equator. From above the Tropic of Cancer and below the Tropic of Capricorn, from the tropics to the poles, just below the poles is the temperate zone. And then the poles themselves, in the Arctic Circle and the Antarctic Circle, are the frigid zones. Now this is sort of a very primitive, simplified classification that we have learned is much more complicated now, but that is how the Greeks first classified the climate. The Köppen classification system. I'm not sure how that's pronounced, but it's Koppen. And the O has those 2 little dots above it. I don't remember what those are called. So this classification system is more modern, and it has A, B, C, D, and E climates. A climates are the humid tropical climates. These are winterless climates with all months having a mean temperature above 18 degrees Celsius or 64 degrees Fahrenheit. B climates are dry climates. These are climates where evaporation exceeds precipitation, resulting in a moisture deficiency. C climates are mild mid-latitude climates. Climates where average temperature of the coldest month is below 18 degrees Celsius, 64 degrees Fahrenheit, but above 3 degrees Celsius, or actually minus 3 degrees Celsius, or 27 degrees Fahrenheit. D climates are mid-latitude climates with severe winters. So D and C climates are similar, but D climates have severe winters. D climates are where the average temperature of the coldest month is below minus 13 degrees Celsius, 27 degrees Fahrenheit, and the warmest monthly mean exceeds 10 degrees Celsius or 50 degrees Fahrenheit. And then E climates are polar climates. Summerless climates, where the average temperature of the warmest month is below 10 degrees Celsius or 50 degrees Fahrenheit. Not on this chart are H climates, and we haven't covered those yet. So, but keep in mind that there is another climate called the H climate, but it isn't here on this chart, and that comes in later. There's a list on the next page that has information about each climate, but the text is kind of small. Even when I zoom it in, it gets fuzzy. So I'm going to skip this one. I think this might also be in the book. I think all of this is covered on the other slides, though. This is just a summary of the climates. Polar climates, or E-climates. Lands beyond the Arctic and Antarctic circles. Polar climates are high latitude. Their climate symbol is E. It says temperature, warmest month, coldest month, and seasonal distribution. But it doesn't say what the warmest month is or coldest month. So I'm not sure where that is going. It says locate the Arctic and Antarctic oceans. Which ocean is best identified by boundaries formed by continents? What are the 3 continents? Which ocean surrounds the continents? So those are some questions to think about. There are pictures here of polar bears and penguins. We mentioned in class, are there polar bears on both poles, and how do you tell the difference? And something I had heard is that Arctic means bears and Antarctic means no bears. So that's something to think about. Is that the name of the polar region actually tells you if there's bears or no bears. If I remember correctly, there's only penguins on one pole, too. I think penguins are at the South Pole. Don't quote me on that, but if I remember correctly. Polar climate tundra. That's ET. E for the polar climate and T for tundra. These are lands beyond the Arctic Circle. Temperatures and the land. Colder summer temperatures cause the size, abundance, productivity, and variety of plants to decrease. So there are less plants because of the colder temperatures. A periglacial landscape with ground ice and permafrost. Peripheral edges of North America and Eurasia. The vegetation is mosses, lichens, dwarf shrubs, stuff that grows close to the ground. The insects prevalent are mosquitoes and black flies. E-climates only occur, or the ET, I should say, only occurs in the northern hemisphere and a portion of the Antarctic Peninsula. Vast stores of carbon and methane are released to the atmosphere, adding to the greenhouse gas problem. That's a quote from Christopherson in the corner. Polar climate with the polar climate ice cap. That's EF. An ice cap is a sheet of continuous ice covering an extensive region. The ice covering remains throughout the year. So the precipitation is less than 10. Vegetation is no trees and stuff that mostly grows on rocks. So like moss and lichen and that kind of stuff. This area is dominated by permanent ice and snow. It is the freshwater repository for life on Earth. The Antarctic ice itself is the largest reserve of fresh water. Daily weather is dominated by dry, frigid air masses. And the major world regions are the North Pole, Greenland, Antarctica, and the South Pole. Barrow, Alaska. Utqiagvik, I think I pronounced that right, or maybe not, also known as Barrow, Alaska, is located on the Chukchi Sea at the southern edge of the Arctic Ocean. It is one of the largest Eskimo settlements in Alaska. It is the farthest northern community in the U.S., and this extreme location means that daylight extremes are experienced. Daylight of 24 hours happens between mid-May and early August. So the average temperatures, there's a chart here with average temperatures and average precipitation month by month. And I won't read that off because it's a lot of numbers to process, but you can look at it. I will read off like their January and August because those seem to be some of their. December and January are their lowest average temperatures, and August is their highest average temperature. So January has minus 1.7 degrees Celsius in January. December has minus 1.5 degrees Celsius, and August has 2.7 degrees Celsius. So that is the temperature variance. It goes from like 1.5 to 2.7. Although in October it says 0.5. Oh, but that's not a negative number. Their precipitation, their lowest number is in the winter as well. From December to March, their average precipitation is 4, and their highest precipitation, which is also in August, is 25. Climatic classification. So these are the steps for climatic classification. Step 1. Divide the calendar year into 2 6-month periods, from April to September and October to March. Step 2. Establish the season and therefore the hemisphere for each set of temperatures. And the reason you establish the season is because different seasons happen at different times of the year in the northern hemisphere and southern hemisphere. So you can compare the temperatures. If you're seeing winter when it should be summer here, then it's the southern hemisphere, and vice versa. So you can rule out half of the Earth's, more than half the Earth in some cases, because the northern hemisphere has more landmass than the southern hemisphere. But you can rule out half the planet just by knowing what season happens when. Step 3. Check for an E-climate. Is the warmest month less than 10 degrees Celsius? If yes, it's an E climate. If not, go to step 4. If it is an E climate, check if the warmest month is greater than 0 degrees Celsius. If yes, the climate is ET tundra. If the warmest month is less than 0 degrees Celsius, then the climate is EF ice cap. Where is step 4 here? Oh, there's a note. Low temperature takes precedence over low precipitation. Any place with all months below 10 degrees Celsius is classified as an E climate, regardless of the precipitation amount. On this slide, we've got step 1 and 2 shown with the calendar year. So there's a chart with all of the average temperatures and precipitation from January to December. And the first step is to divide the calendar year into 2 6-month periods, from April to September and October to March. And basically what you can do is just draw a line between March and April and between September and October, and that divides the chart into, it looks like 3 sections, but because the seasons are separated into, you know how it's like the school year where the winter season goes from last year to this year. So, or really just the winter season in general, not just the school. But so you've divided up your calendar into 2 seasons, but it looks like 3 sections because of the winter season wraparound. Then you establish the season and therefore the hemisphere for each set of temperatures. So in this chart, which looks like the Barrow, Alaska one, let me see. Yeah, in this example it's the Barrow, Alaska one, and you can tell because July is 1.4 degrees Celsius on average, and January is minus 1.7 degrees Celsius, and this tells you a couple things. One, it's very cold, and it matches Barrow, Alaska, but it also tells you that the warmest month is in summer, in our northern hemisphere summer. So we know that this location, even if we didn't know it was Barrow, Alaska, we would know that it is in the northern hemisphere. Step 3. Now check for E climate. Is the warmest month less than 10 degrees Celsius? If yes, it's an E climate. If not, go to step 4. If it is E, then check if the warmest month is greater than 0 degrees. If yes, the climate is ET tundra. If the warmest month is less than 0 degrees Celsius, then the climate is EF ice cap. So something to think about is 0 degrees Celsius is freezing. So if the warmest month is always freezing, it's always going to have ice, because they never have temperatures to melt the ice. Step 3. Oh, yeah, it's just another slide with step 3, but it does show a chart comparing the average temperature, which I'll skip because it's really more of a visual. So this chart, there's a little thing in the corner for an example. It says the warmest month is 2.7 degrees Celsius. Therefore, the warmest month is less than 10 degrees Celsius. So this is an E climate. So the little chart on step 3 is an E climate. The next slide says, well done, but we're not done yet. So let's keep going. Arid climates, B climates. So B climates are dry climates. They lack moisture. BWH and BWK, which are the latitudinal deserts, between 0 millimeters and 25.4 millimeters. So there's a lot going on this picture, but I also know that this will all be covered on the next slides, and it'll be easier to read there. So I'm going to head over to the next slide here. Dry climates are characterized best by their lack of moisture. Where are these dry areas concentrated? What are the natural causes, not human inducements to climate change? A true desert will have less than 254 millimeters of precipitation in a year. Caution: in doing step-by-step climate analysis and calculating the value of R, the boundary between wet and dry climates hovers near 482.6 millimeters of annual precipitation. Concentrations: along tropics of Cancer and Capricorn, in a 10 degrees to 15 degree band, in influence of high pressure. That says 10 degrees to minus 15 degrees. Continental interiors. So, for example, there's a picture here of South America, which has this curve on the left side of the landmass, which makes this little continental interior, which is a good place for a B climate to be. Causes are wind direction, high pressure, cold ocean currents, and rain shadow. So rain shadow, I learned what this is with my rain bucket. So I have a rain bucket, and you can't put it underneath any trees because the trees will hold on to water when it rains, and then when the wind blows, they will dump the water onto the ground and into the bucket. So it looks like it has rained when realistically the sky has not rained, the tree rained. The tree held on to water, or something held on to water, and it dumped it into the bucket to give a false reading. And that's what rain shadow is. Arid climates. I'm going to make some coffee before I read any more because it's this early morning air is not helping me read. All right. Arid climates. So there's BWH, which is a low latitude desert that is hot. A BSH, which is a low latitude steppe that is hot, which in a minute we'll get to what a steppe is. A BWK, which is middle latitude desert and cold, and BSK, which is middle latitude steppe and cold. So one way to remember that is the H at the end is for hot, and the K at the end is for middle. H for hot is pretty logical. K for middle, I don't know. Maybe the K has a little line in the middle. It looks like a little kicking person. I don't know. But if you can remember that H is hot, then rule out K. K is in the middle. And also K is cold. Hey, that there. K for cold. Alright. A steppe, in the context of a climate, is an area that is considered to be dry, but that is considered too dry to support a forest, but too moist to be a desert. Steppe land areas are primarily found in southeastern Europe and Siberia. These are grasslands that support grazing animals, and in history the peoples who migrated followed the animals, who followed the rains. So an example of a savanna, or an example of a steppe would be like the savanna. Like in Disney's Lion King, you could watch the Lion King and see a steppe in the savanna. Cold desserts, like ice cream. No, it's cold deserts. Where is a cold desert, and how can this be? Precipitation is a true desert, true desert by definition. Just a minute. The coffee machine is making noise now. I always think it sounds like a tubby custard machine. I guess it's not cool to talk about your preschool, toddler age TV shows, but it sounds like a tubby custard machine. And yes, it's a Keurig style machine. It's not actually Keurig. I think maybe Keurigs are quieter. Gonna let that finish up. So noisy. Alright. Alright, where were we? Precipitation in a true desert, by definition, has 25.4 millimeters or less of moisture in a year. So, very dry. So deserts are not defined by being hot or being cold, they're defined by dryness. Review of bee climates and classification. Williston, North Dakota. Let's see. We already know that's in the northern hemisphere. But their warmest month, let's see, looks to be in July with 21.2 degrees Celsius. And their coldest month is over here in January, which is minus 11.7 degrees Celsius. So it's not an E climate. I think we're going to go through the steps here to figure out what kind of climate it is. So step 1 is to divide the year into 2 6-month periods. So we've got summer and winter. Establish the season and therefore the hemisphere for each set of temperatures. We already know that the warmest month is in the summer, coldest month is in the winter. Spring and fall are kind of cut into here, but summer and winter are the defining seasons for the calendar. Now check for E climate. Is the warmest month less than 10 degrees Celsius? If yes, it's an E climate, but it's not because these are the same numbers for Williston, North Dakota. And summer is right in the middle of the calendar where it should be for us in the northern hemisphere. Temperature takes precedence over low precipitation. Any place with all months below 50 degrees Fahrenheit, 50 degrees, that's different than what's said on the other slide. That can't be right. That's 10 degrees. Regardless of the precipitation amount. I've got to go back and check now. Is the warmest month less than 10 degrees Celsius? Yeah, that's just a typo. So if you see that should be 10 degrees, not 50. Oh, 50 degrees Fahrenheit. There we go. So 10 degrees Celsius, 50 degrees Fahrenheit. I see my mistake there. Not a typo. That was my mistake. Let's see. Although maybe you'll be able to remember 10 degrees Celsius and 50 degrees Fahrenheit. Maybe it was a good mistake. Alright. Yes, we know that the warmest month is above 10 degrees Celsius. If the climate is not E, then determine the precipitation boundary R between the dry climates. So B and the humid climates A, C, and D is what we're trying to figure out. Which of these climates is our climate? It is at this point where only one of the 3 equations below will be used to solve for R. Summer precipitation concentration. Wettest summer month is at least 10 times greater than the driest summer month, or driest winter month. Winter precipitation concentration. Wettest winter month is at least 3 times greater than the driest summer month. If there is neither summer nor winter concentration of precipitation, I think that's when the precipitation kind of flatlines. Everything's roughly the same every month, the precipitation levels. I think at that point you can pretty much rule out a declimate, because declimate has severe weather, it has severe precipitation. So I think you could rule that out there, but if there is neither summer nor winter concentration, then there's another math formula to use. And I'm not going to read off all the math formula because I'm terrible with math terminology. I forget it all the time. So I see all the symbols, but I'm not even going to try to attempt those. I will get them wrong. After determining R, you go to step 5. Okay. So T equals mean annual temperature, and A equals the total annual precipitation. A mean is the same as an average. So it's the average temperature is T. T is at this point where only one of the 3 equations will be used to solve for R. Well, this seems to be a similar slide with the same material. Summer precipitation concentration, winter precipitation concentration. Okay. To get T, you need to take the average of all the monthly average temperatures. You do this by adding all of the monthly temperatures, then divide them by 12, which is the number of months. Because to get an average, you add up all of your numbers, and then you divide it by the number of numbers you have. So we have 12 numbers because we have 12 months. So it's the combination of all the average temperatures times 12. So in this example, February is the driest winter month with 10.2 millimeters. And I think it looks like it's between June and July. I think that's maybe June, maybe July. Wettest summer month is 63.5. Okay, June and July are both the wettest summer months because they have 63.5 millimeters of precipitation. So they're tied. So the driest winter month is 10.2. There's a little math equation here. It says 10.2 times 10 equals 102 millimeters. 63.5 is not 10 times greater than 10.2. So the wettest summer month, 63.5 millimeters, and the driest winter month, 10.2 millimeters, means the wettest summer month is not 10 times greater than the driest winter month. So we go on to the next equation. Winter precipitation concentration. Let's see. The driest summer month is 25.4 millimeters. That's April. And October is the wettest winter month, 22.6 millimeters. The wettest winter month at 22.6 millimeters is not greater than 3 times the driest winter month, 25.4 millimeters. So, alright, I think I'm starting to understand something here. So, the summer precipitation concentration equation is where we are trying to see if the wettest summer month is at least 10 times greater than the driest summer month. That's the summer precipitation concentration. And the winter precipitation concentration, we are trying to see if the wettest winter month is at least 3 times greater than the driest summer month. So in this case, the wettest summer month is not greater than 3 times the driest summer month. Which means we have neither the summer nor winter concentration. So if you have a summer precipitation concentration, there is a formula for R that is different than if there's winter precipitation concentration. That's a different formula. And if you have neither summer nor winter concentration, that's a third formula. They're not exceptionally different. I will try to read them off. So for summer, R equals parentheses 0.44 T, that's the average temperature, is T, minus 3.0. The winter precipitation is similar, R equals parentheses 0.44 T minus 14.0. And if you have neither summer nor winter concentration, R equals parentheses 0.44 T plus 13.06. So the only variable it changes is the whether you add or subtract and what this number you add or subtract is. And so you use these formulas depending on the situation to figure out what R should be. And once you determine R, you go to step 5. Winter precipitation concentration. So that's that R equals 0.44 T minus 14. When the wettest winter month is at least 3 times greater than the driest summer month. There are several steps to this equation that I am not going to read off. Actually, no, I'm going to try and read this off. I'm going to try. So we have the equation for R, which for some reason it has the non-winter or summer equation. I think because in our previous example, we determined that it wasn't summer or winter precipitation. So that means it's plus 13.6. Even though it says winter precipitation up here, I think that's just there. I don't think that's related to this problem. So the average temperature we found earlier, that's the average of all of the months on the calendar, is 5.3. So we insert the value of T. So inside the parentheses, we put, we replace T with another set of parentheses, 5.3. So, and then we add 13.6. Multiply 0.44 by 5.3. That's how we solve this parentheses problem. 0.44 times 5.3. That's your T average that we found earlier. So we get a number of, we get the answer 2.332 plus 13.6. Then you add to solve the equation. So that 2.332 plus 13.06 equals 15.392. That 15.392 is your R. Then you convert R to millimeters. I'm not sure where the second number comes from, but R equals 15.392 times 25.4, which equals 390.96 millimeters, I think. Yep. So R equals 390.96. And that's a very rough explanation of the equation. And the toughest part of this is the parentheses, 0.44t, and it explains how to do that. So if you're confused, look at the slide. It'll explain it visually. And the number that changes depending on what kind of precipitation you have on your chart is this second part, which isn't as difficult. It's just addition or subtraction. All right, step 5. Now check for a B climate. It is not a B climate if the total annual precipitation is greater than R. Because if you remember, B climates are dry, so they can't have a lot of precipitation. So on this slide, the precipitation is added together for a total of 365.76. So A represents this total. A equals 365.76. And that is the total amount of precipitation in the entire year. And it's important because we need to check this against a B climate, and we need to compare this to R, because a B climate's total precipitation cannot be greater than R. So R equals 390.96 and A equals 365.76. So the precipitation is not greater than R. So now we go to step 6. We have a B climate. Now we need to determine if it is a BW climate or a BS climate. If the total annual precipitation is less than R, I forgot what a slash symbol means. A forward slash. So if the annual precipitation is less than R/2, it is a BW. It's a desert. I looked up what the slash is called. It's just called a division slash, or an obulus if you want to be obulus, if you want to be fancy. But no, that's R divided by 2. So R equals 390.96 190.96, R divided by 2 which R is 390.96 divided by 2 is 195.48. So R divided by 2 is 195.48, and A, our average, or not average, our total annual precipitation is 365.76. So A is not less than R divided by 2. So if the total annual precipitation is less than R, which it is, then you have a BS steppe climate. Now we need to determine if the third letter is an H or a K. H is if the coldest month is greater than 0 degrees Celsius, and K is if the coldest month is less than 0 degrees Celsius. So the coldest month in our example is January. And January is minus 11.7, which is colder than, that is less than 0 degrees Celsius, which means that it is a BSK mid-latitude steppe cold climate, because that K stands for cold. So Williston, North Dakota is a BSK climate. And that's what we figured out through this whole process. So if you go back and look at those steps and break them down, you should get a good idea of how it works. Just walk through it, give it some thought, and it should start to make sense. So now we have tropical climates, which are A climates. There's AF, it says rainforest, AW, savanna, and AM, monsoon. Tropical climate characteristics. They are located in the tropics. The coldest month is greater than 18 degrees Celsius. They are winterless. It says migrate following the ITCZ. I don't quite remember what migrates. It'll take me a minute, but that might get explained in a future slide. And they have excess moisture. There are 3 subclimates. AF, tropical rainforest, which you could think of F for forest. AM, monsoon, M for monsoon. And AW climates, which are savanna climates. I haven't thought of how W relates to savannas yet. That's going to take me a minute. So it has the climate symbol A, because it's an A climate. The largest rainforests are integral with large volume rivers. Can you make a statement as to their connection? The best examples include the Amazon and Congo river basins. AF, tropical rainforest, is monotonous, and it's a jungle or the boonies. So any climate you might describe with those words are an AF tropical rainforest. Carbon sink, an area of the natural environment such as a forest or ocean that absorbs carbon dioxide from the atmosphere. Rainforests can absorb carbon dioxide, which is a byproduct of burning fossil fuels. What creates the pronounced seasons? Shifting pressure belts is the basis for the answer. In the A climates, the shifting subtropical high pressure belts and the ITCZ low pressure create conditions in the atmosphere for rain or no rain, thus wet and dry. The slide mentions AM tropical monsoons with a pronounced wet season, and AW tropical savanna pronounced dry season. So I think that's related to what I just read down here. The shifting subtropical high pressure creating conditions in the atmosphere for rain or no rain. So this next slide is Dar es Salaam, Tanzania, which is the largest city and economic capital of Tanzania. On a climograph, one should include statements about economic activities, especially those that are connected to and/or represent the climate. Conduct your own research to learn about mining, agriculture, urban development, immigrant labor, and remnants of colonialism. Temperate climates, sea climates. Mid-latitude climates. Let me go back here and see if there's anything in these pictures. Yeah, I'll move past the pictures. There are several interesting pictures here, but I'm not going to explain them right this minute. Mid-latitude climates. They are characterized by short-term day-to-day and week-to-week weather changes, long-term seasonal contrasts, nothing is constant, distinct seasons. Air mass conflicts occur, therefore frontal boundaries. Temperature is more important than precipitation, and they have the greatest weather variability. Humid mesothermal characteristics. Mild winters, hot summers. 55% of the world's population lives in this climate region and growing, so in sea climates. And there is tremendous agricultural potential. Humid subtropical. Characteristics found on the southeastern region of continents. Distributed moisture throughout the year. Winter cyclonic storms that produce severe thunderstorms, tornadoes, and/or snow. Marine west coast. Characteristics. moderated by water, thus the marine effect, and there's precipitation throughout the year. Describe the distribution of precipitation that supports agriculture. There's a picture here of precipitation in Dublin, Ireland. Difficult to see the numbers, but you can see there's precipitation throughout the year because Ireland is a CFC climate. Mediterranean, CSB. Climate descriptions characterized based on land are encircling the Mediterranean Sea. Also found on the west side of continents. There's some words here behind the pictures that I can't see, so I'm going to skip past that. But the pictures are of grape vineyards and of Cape Town, South Africa. And I believe that's another precipitation map from Greece, because these are all in Mediterranean climates. The CSB. Istanbul, Turkey. What does the land look like? There's some pictures here. One is of trees that look very dry and not very healthy. The soil looks very dry, almost sand-like, although it probably wasn't sand originally. This was probably, it looks like a drought here. Let's see, there's a temperature profile, temperature and precipitation. The warmest month looks to be August with 23.2 degrees Celsius. And the coldest month looks to be January with 5.7 degrees Celsius. And for precipitation, the wettest month is December with 124, and the driest month is July with 24. Continental climates, D climates. D climates are similar to C climates, but they have severe winters. They're characterized by short-term day-to-day and week-to-week weather changes, long-term seasonal contrasts, nothing is constant, distinct seasons. Air mass conflicts occur, therefore frontal boundaries, and temperature is more important than precipitation, all like a sea climate, and greatest weather variability. But they also have severe winters. Humid microthermal. Severe winters, mild summers, very distinct seasons, good agriculture, and dominated by something that the word is hidden behind a picture. I don't remember what that word was, so I'm going to move past that. Humid continental. DFA, DWA is a long summer climate. DFB and DWB is a short summer climate. So the climates with A at the end have long summers, and the ones with B at the end have short summers. I'll have to think of a clever way to remember that. A and B. Makes me wonder, remember that show Phineas and Ferb? I wonder if they have long summers or short summers. Wonder which climate they live in. Points to make. Hot to mild summer. Long growing season, most agriculturally productive. Cyclonic storms, and distinct seasons seen in deciduous trees. In D climates, when you're looking at a chart, there's a chart here for Muskegon. This Muskegon climate graph has a sort of bell curve looking. It's where the data on the chart sort of looks like a mountain. It goes up and then comes back down like a hill. And the reason why is because you're seeing an extreme low and an extreme high charted on the data. Subarctic, DFC, DWC, DFD, DWD. Are there D climates in the southern hemisphere? The answer is no. Points to make. Brief, cool summers, long and very cool winters, and pronounced continental effect. That's subarctic. Seoul, South Korea, we have a temperature profile. It looks like for temperature, their highest temperature is 25.9 in August, and I think over here in February, minus 0.8. In which Korea will you find Seoul? Astronauts flying on the International Space Station took this image of the Korean peninsula. So there's a picture here of the city lights in Korea. Kind of cool. H climates, highland climates. Now, when I started this recording, I said I wasn't going to do H climates just yet because we hadn't covered it, but by this time we have covered it in class, so we can do that in this video. Finish up with H climates. So H stands for highland climate, although it has nothing to do with the highlands of, Scotland? That is not an H climate, ironically. Highland climates. So, altitudinal zonation is a vertical classification based upon the environment, how the land is used, changes in climate, temperature and precipitation. It says T and P, which I think mean temperature and precipitation, and changes in vegetation. All of those factors make up the classification for altitudinal zonation. And there's a chart here. Agricultural and human use of the land conforms to the zones. All right. There's a chart that shows different climates at different altitudes. So basically, the other climates are not based on altitude. Highland climates are based on the altitude of the land. So we have Tierra Caliente, which is about at sea level. At sea level, you have sugar, bananas, cacao, tropical rice, coastal plains, and lowland interiors. Those are all things you find in Tierra Caliente. It's 60 degrees Fahrenheit to 90 degrees Fahrenheit, and it's at sea level. Then at 2,500 altitude, you have a Tierra Templada, which is 50 degrees Fahrenheit to 80 degrees Fahrenheit, which has coffee, wheat, cotton, beans, tomatoes, peppers, and some citrus, and the largest populations live here. At 6,000, we have Tierra Fria, which is 40 degrees Fahrenheit to 70 degrees Fahrenheit. And if you notice a pattern, it's rising in, or as you rise in altitude, it's lowering in temperature by 10, which is similar to the mountain problem, where temperature decreased as you went up the mountain. You can see the same thing here. So, Tierra Fria, potatoes, tubers, barley, plums, peaches, apples, and a large percent of land is in this zone. There's a tree line at 12,000 where there's livestock grazing. And then at 15,000, at the top of this chart here, we have Tierra Helada, which is below freezing, and you have ice and permanent snow. Tierra Caliente. Characteristics. A distinct tropical climate, think A. Continuous hot weather, think A. Along coastal plains, areas near the equator, little seasonal temperature variation. Colonization dominated much of the land used in these coastal areas. And plantation farming includes bananas, sugarcane, and bamboo. Tierra Templada. Characteristics are a cooler environment in comparison to the Tierra Caliente, coffee, corn, wheat, cotton, beans, tomatoes, peppers, some citrus, and the largest populations in South America are found in this zone. Characteristics. Let's see, which one are we on now? It says Tierra. It's probably the next one. I think the word got cut off. That's the Tierra Fria. Tierra Fria. Characteristics. Temperatures are significantly cooler, can even be frosty. Crops and natural food products are described as cool weather foods. Potatoes, tubers, barley, plums, peaches, and apples are easily grown, and a large percentage of land in South America is in this zone. So South America has H climates. Tierra Helada. Characteristics. It is too cold to grow crops, so they herd llamas in Tierra Helada, because that's at the very top, and it's freezing, and there's not very much that wants to live in those conditions as far as plants. Many live next to mines. Highest places with human habitation are in the Andes Mountains. Montane grasslands are found in areas of high altitude. The grasses provide grazing for livestock, which are the mainstay of life for people living in these regions of the world. This next slide is a picture of different climates around the globe. It's basically a qualitative climate map. So you can see this first slide is North America and South America, and each climate is color coded. And this last slide, which I think is the last slide of them all, is Africa, Europe, Asia, Australia over here. So you can take a look at those two maps, and those have the climates. So that is all the slides. I'm going to try and do the review slides. I don't know if I'll have time because tomorrow is the exam, but I will try to get that finished up and ready for you guys in time. So, correction. I do not have the review slides in the Canvas, so I won't be doing the review slides, but I'm thinking I can either do the homework assignment review, like read off some questions from our homework, or read some of the book, maybe chapter 15 specifically, because we struggled with climates a lot in the review. So, yeah, again, we're going to do awesome. I'm going to try and do a couple more audio readings. At least one more, but we'll have to see if I have time. So, bye, and let's go ace our exam.